Alright, so a particle of unit mass is projected vertically at 20 meters per second in a medium where air resistance is of a magnitude of v squared on 100. Okie dokie. So it's 20 meters per second when it goes up, and there's a resistance going on as well as a resistance of gravity, which is 10 in this case. So find the time taken. So we've got time to reach maximum height. So at maximum height, we do know velocity equals 0, so that's handy. Alright, so it does say time taken, so straight away when I find my equation of motion, which in this case is going to be, so I'm gonna go straight with dv dt, which is acceleration. So I've got both things going down. I've got gravity, which is 10, and I've also got v squared on 100. So again, this is unit mass, so I didn't have to get confused about whether mass should be with it or not, because I'm dividing by 1 anyway. Alright, so find the time taken. So we want t the subject, so I'm going to actually make t the numerator, and if I make a common denominator here, I'm going to have 100 as my common, which becomes a numerator. So on the bottom I've got 1000, which is not 10 squared, it is 1000, and v squared on the bottom. So for my t, I am going to integrate with respect to v, so I'm going from v equals 20, remember, up to 0, and I'm going to, I should put that 100 out the front. Put that 100 out the front, and what am I left with? dv on, oh, I've already written that, on this. So it's not a log this time, it looks like inverse tan. So let's be a little bit careful. So first thing I might do is, I'm going to keep that 100, but I'm going to go from 0 to 20 instead of minus 100. I'll go like this, so 0 to 20. Now remember, with our inverse tan, we've got our v, we've got to be careful with our what we get out the front. So we are going to get 1 on the square root, our a squared, so our a is square root of 1000, so 1 on a, inverse tan of v on square root of 1000. Between 0 and 20. So if I put that out the front, so 100, I can put 100 over square root, or I could put that in the square root, and then I've got 100 times 100, which is 4 zeros under the square root. So 10,000 divided by 1000. So I'm just going to get a root 10 left. Hopefully you're okay with that. So what I did do was I said 100 squared so that I could put it in a square root. Then I could put this in the square root as well, like that. And then I could use it to, the squared means 4 zeros, so 1, 2, 3, 1, 2, 3. So I got square root 10 left. So square root 10 inverse tan of, so when I put, let's just do this, when I put 20 in, when I put 0 in I get zeros, when I put 20 in I get 20 on square, so this is 100 times 10, so it's 10 root 10. That means it's 2 on root, oh, I feel like I've got that wrong. 2 on root 10, 2 on root 10 times root 10 on root 10. Hopefully you can follow me, is, so I've got 2 root 10 on 10, so it is root 10 on 5. So if I wanted it to look nice, I would say, which equals root 10 inverse tan of root 10 on 5. That is the time. If you put that in your calculator, we get 1.8 seconds. So you don't have to make it look nice, like you don't have to rationalize the denominator, you could find it straight away. It says to 1 decimal place. I just didn't read the question. Alright, so that's to 1 decimal place, that's the time taken. So what are we going to do next? We want to prove the maximum height is h equals, so it's an actual thing there. Alright, so we want the maximum height, so we need to really go back and go find the maximum height. I need the x, and it occurs when velocity is 0, so I need to change this equation of motion, and I'm going to go v to v dx instead of v to t. So v to v dx instead, oops, that is a minus there. So everything is the same except, well, nothing's the same now, so get rid of that. So v dx is equal to minus, remember this is times 100 if I want it all on 100, and I'm dividing by v as well, and I am going to tip that upside down and make that an h. So this is going to be, with respect to v, where am I going? I'm going from 20 to 0, aren't I? Same as before, but I've tipped this upside down, so I've got 100v on 1000 plus v squared. So this time it is a log because I want 2v up the top there, so I've got 100, so I'll put 50 of that out the front and make that a 2 instead, so I've got 2v up there. So again, I can get rid of this minus by swapping these, making this 0 to 20 as well. Hopefully you're okay with me scribbling there. So I'm integrating 2v on 1000 plus v squared, which is log of 1000 plus v squared, from 0 to 20. So I've got 50 log 20 squared, so we end up with 1414. So we end up with 1400, because that's a 400, yes. 1400 log, oops, 1400 on, put 0 in, you get 1000. Alright, so you get 14 on 10, which is 7 on 5. So it does equal 50 log 7 on 5. Thank goodness, because that's what we wanted to find. Alright, and C, prove the velocity just before the particle impacts the ground is that. Alright, so just before it impacts. Now, we're going down, so we're going to have to change our motion. But we know we're interested in velocity, so we definitely want v. And just before it impacts the ground, so really we want that whole distance from 0 velocity down to this velocity. So we still want our x. So again, I'm going to use v to v dx. But this time it's going to be 10 will be positive because gravity is going with motion. So I'm going to go back to here. So this time 10 is with motion, but I've still got v squared, the resistance happening. Alright, so v dx being, so again this is 100, and we want v, we're dividing by v, but we're going to tip it upside down, so we're going to have an h there, that will come in handy. So we're going to get 100v on 1000 minus v squared again with respect to v, and this time we're going from the top to this velocity at the bottom, which we're trying to find here. Alright, so we know we've already found this h, so I know this side is 50 log 7 on 5, so always looking for hints and trying to use what I've already got. Alright, so here I want to do the same thing I did before. I need this to be negative 2v, so I'm going to make this negative 50, and that gives me a positive 100 there. So this is going to be, well, that's handy, because actually I'll make that a plus and go from v to 0, and now it's a log of 1000 minus v squared. Okay, now those 50s I can divide by 50, and here I'm going to get on this side log of, when I put 0 in I get 1000, when I put v in I get 1000 minus v squared. So you can see now if I exponentialize both sides I get 7 on 5 is 1000 on 1000 minus v squared. Alright, So let's time. So I'm timesing this whole bit over to the other side. So I've got 7,000 minus 7v squared, and on this side I've got 5,000. So if I make, I'll do this first, I'll do it nicely. Actually, I'll make it positive and put it on the other side. So I can probably confuse this so much, don't I? So here, the 7,000 take away 5,000, so that's 2,000, and 7v squared can be on that side, and then divide by 7, and square root as well. So again, running out of room, so v squared is equal to, now this is 2 times, let's say 20 times 100 is 2,000, so 100 is 10 squared on 7. So then when we find v, we would square root the 20 and the 7, but square root of 100 is 10. So we've still got the 20 and 7 there, but the 10 can come out. So that would be the exact, oh, there we go. That's what we wanted.